Hi everyone. I would like to show you how to do some of the regression that Field has in his book. This is just for practice, but sometimes I find that if it's in a video, plus you've got pages in the book, and you can pause the video, go to the book, come back to the spreadsheet, and hopefully you'll be able to create on your computer the same things that Field has created in the book. So make sure that you have the Field book open and turn to page 315. Then also make sure that you have the spreadsheet open. And the spreadsheet that we're using is the album sales spreadsheet. And I've got it up in the module for this week. Make sure that it can open. If you're using the remote lab and it's not opening, then perhaps you're trying to open it outside of the remote lab, or perhaps you're on a computer that doesn't have SPSS. If you run into these kind of problems, please contact me. But if once you open this spreadsheet and open your book, we're ready to go ahead and start with this idea of looking for problems with our data. We're not going to use the same level of detail that Field uses because this is a semester-long regression course and we have a lot more to do. We can't spend our entire semester on residuals and H-hats and some of the things that Field talks about. But what we can do, and the responsible thing to do, is just quickly look at our data. So let's make a graph. In this example, Field is interested in an advertising budget, how much this company is spending on advertising, and then hopefully the sales, seeing if the sales are influenced by the advertising. He's hoping for this kind of a positive linear relationship. As advertising goes up, then sales should go up. And so we're just going to look first at this relationship in a correlation type of a setting in a scatter plot. So come in here to graphs and grab the chart builder. Okay, and let's go. Yours will probably open with these bar charts showing. What we really need here is a scatter plot. So highlight this scatter dot option. And then we'll just highlight this very first scatter plot right here, this simple scatter, pull it up into our chart preview, and then we'll pull our variables over. Now notice that Field has advertising budget on his x-axis because this is the independent variable. This is the variable that we can manipulate. We can put more money into the budget or less money into the budget. And then he puts album sales on his y-axis. This is our outcome variable. This is the variable that we hope is influenced by the independent variable. So album sales are dependent on the advertising budget, our dependent or outcome variable. Now these little dots in here are just automatically populated by SPSS. They do not tell the story. They are not our data. Let's go in here and click OK, and we'll get a graph of our data. Okay, here it is. This is our data. Just take a quick look. Do you see anything that looks completely out of place, that looks like it may have been recorded incorrectly, or perhaps a participant or a measurement that we're going to throw out because the participant didn't follow instructions or dropped out of the study? We have some reason for that. And I don't see any. All of these look pretty reasonable to me. So now what I want to do is put the line of best fit through here. And mine says double click to activate. So I am going to double click. If you're on a Mac, you may need something a little bit different. Perhaps double clicking will do it, or you may have to experiment with left or right clicking. But once you activate it, the graph comes up in a separate window. So here's my activated graph right here. And I want to include this line of best fit. So I come in here, and you see here on this little menu, it says Add Fit Line at Total. I'm going to click on this line right here, and it opened up a dialog box over here. So notice this dialog box. I want the linear fit line. I'm going to take it exactly the way it comes. In fact, it's already there, so I can close this box. And now this is one of the things about SPSS that makes me so nervous. I've got my line of best fit. I like it. Everything's good. My instinct would tell me to save this, but that's not how SPSS works. SPSS wants me to go ahead and close out this chart editor. And when I do, my line of best fit actually appears in my output. Ta-da! So here's my line of best fit. Here's my graph. And what I'm going to do now is, for me, it's a right click. I'm going to copy this. And I usually click on Copy Special because sometimes the files don't copy into Word the way I like them to. So I've clicked on this image. This gives me a few possibilities for pasting this. I click on OK. And then I've already got a Word document open. I would like you to open a Word document and to think about the write-up, which will be in my next video. I'm going to paste this scatter plot right into my write-up. And then in the next video, we'll talk more about why it's there and what I might want to say. For now, though, I want to go back to SPSS. I've put my scatter plot in there. It's got the line of best fit. There aren't any red flags. I'm ready to move on to regression. And so now look at page 317 in the field book. He's going to create a regression box for us by coming into Analyze. You see Analyze up here. Coming down to the regression option. So far, so good, right? Then in the regression option, we are going to choose linear. That's your second option from the top. Choose linear. And then we're not going to do the bootstrapping, the confidence intervals. We're just going to go straight ahead with the very simple linear regression. In our dependent variable, we're going to put the album sales because that's what we had on our y-axis. That's the thing that is the outcome variable. And in our independent variable, the thing that we're controlling or manipulating, we're going to put our advertising budget. Unfortunately, SPSS calls this block 1 of 1, so they use some language that's not really familiar. Notice in the book, it is independent, but this newer version has changed some of that. We're set though now. We've got album sales as dependent, block 1 of 1 is independent, and I'm just going to click OK. When I click OK, these are the outputs that I received. So it tells me that I entered the variable of advertising budget. It gives me a model summary right here, and there are some things in this model summary that I want to keep. I want to keep my R² value. Now, I already have that here from my, my scatter plot, R² linear 0.335. Let's go back and check the output. R² 0.335. Okay, we're good. We're good. I've got my R². Next comes an ANOVA table. Now, wait a minute. We didn't do an ANOVA. We did regression. ANOVA's coming up here in a couple of weeks. But regression and ANOVA are both based on the sum of squares, and they actually use the same map and the same ideas. And so in SPSS, in SAS, in R, when we do regression, we come up with an ANOVA table. Are there things in here that are important? Yes. there's an F statistic, and I'm going to go ahead and type this F statistic, which is 99.59. We round off to two variables. I'm going to type 99.59 here into my Word document. Okay, that is my F statistic, and I actually need to say F and then put my degrees of freedom in here. So let's go back to our output. We'll talk about degrees of freedom all semester, but my degrees of freedom are 1 and 198. Okay, so my first one, my second one, 1 and 198. I'm just going to type 1, comma, 198 equals, and then here's my number, 99.59. Okay, and here we'll type in R squared when we finish our document. We've already got that. The next thing that we need to pull off of this output is our coefficient. Now, interestingly, we almost never care about the constant, and we'll talk about this in class too. For example, look back at our graph here. The constant is it's 100. I'll just pull it from here really fast. The constant is 134, and you can see right here where the line hits 0, where the line hits the y-axis, it's 134. What the constant means is if I didn't put any money into advertising, I would still sell 134,000 albums. Sometimes that's not a great measure. For example, in height and weight, we might say even if you're 0 inches tall, you still might weigh 50 pounds. It's kind of nonsensical. It comes with the line of best fit. And so we almost always, I would say 99.9% of the time, we ignore it. SPSS and some other programs give us the option of forcing the line of best fit to go through 0, 0. That means that we're assuming, well, of course, if I'm 0 inches tall, I should weigh 0 pounds. Or if I don't advertise at all, I shouldn't sell anything. And the problem with that is we're measuring data in a different area. We're not measuring data where people are 0 inches tall or where there's absolutely no advertising. And so to try to force the line to go a certain direction where we haven't measured data actually ends up giving us a poor result. So what we do is we just ignore the constant. We can talk about this more in class too. Instead, what we're interested in is right here, this advertising budget. And we're interested in the beta, which is 0.578, and we're interested in the t. Okay, so let me put the beta, and it is 0.578, and then let me put in that t, and once again we have to put degrees of freedom. The degrees of freedom for t are here in our output. Actually, let's see here. Nope, we'll have to do degrees of freedom on our own. The degrees of freedom for T are actually 198. That's fortunate, isn't it? So 198, and then that T is the second one. Remember, we don't want this first one because that's our constant. We're going to ignore this whole first line. We're going to come to the second line. T with 198 degrees of freedom is 9.98. Okay, so T 198 equals 9.98. Okay, And then the prediction equation is already on our scatter plot. That's one reason I love the scatter plot. So we'll come back and type that up here in a minute. Actually, no, let's type it up from our outcome, because on the scatter plot, it looks like they rounded it off a little bit. So our equation is, and let's use words that the sales, that's what we're trying to predict here. So sales, no, sorry, I can't spell. I'm doing too many things at once. Equal, they equal the t-statistic 0.578 times, I'll just use a little asterisk for times the advertising plus, and here's where we finally use the constant, because actually we don't ignore it forever. It's a very important of our equation, plus 134.14. Okay, 134.14. Then we can tell our advertising people or our whoever it is that we're talking to about advertising that you can predict the sales, the dollar amount of sales, if you take the dollar amount put into advertising. Actually, I think sales was number of albums. Forgive me. The number of albums is 0.578 times the dollars, or in this case it's pounds, it's British pounds, put into advertising plus 134 extra pounds. And it's pretty powerful. In the next video, we'll talk about writing this up. But for now, those are the only two things that are really important to do in SPSS in order to come up with everything you need for a regression paper, a regression discussion. And we call this simple regression because we're taking one variable and using that variable to predict another. Okay, thanks for watching. Have fun trying this. You may want to see if you can use the variable airplay to predict the sales. Or maybe you can use the variable sales to predict the airplay. The more albums you sell, will the higher the airplay be? And who knows if attractiveness of the band can be used to predict any of these others. But it's fun to play with and try, so give it a shot. Thank you.